Electron orbital modeling. User prompt. I'd like to discuss electron orbitals from the perspective of them still being actual particles traveling through space with actual locations, charge velocities, etc. I believe that this interpretation still has merit and potential fruit to bear, and that it has possibly been discarded too soon, that it's possible that it could still be accurate, but even if it's not an accurate actual physical representation of what's going on, it could be potentially useful in analysis and understanding of electrons and abstract logic in general. From my initial attempts at modeling atoms with particle models, a single electron flying around a nucleus would have a force pulling it down similar to gravity and a force pushing it to the side causing it to orbit. Obviously, in a chaotic system, practically every arrangement is possible. When I heard about the three-body problem, I heard about modal building blocks, kind of like Legos for orbit paths. That complex chaotic systems could be interpreted as combinations of these more basic formations. E.g., you could have an orbit that is circular, that the whole system is rotating, so the object could be orbiting in a flat straight circle, but the camera could be panning around the orbit in a way to make it look like it is doing something more complex. She could have basic shapes like figure 8 circles, rectangles, etc., or rounded rectangles, all kinds of stuff, but these base models or building blocks could simplify very complex arrangements or orbits, kind of like prime factorization, that you can take very big complex numbers and reduce them down to a few base models of primes. So a single electron system could go in a circle, oval, line. And you could interpret it as a cable teeter-totter. E.g., the electron and proton act like they are connected by a spring in a straight line, and if you lock the reference frame to the proton and electron, then it looks like they don't orbit, they just get closer and farther sometimes. 2 electrons around a single nucleus. Electrons and protons are attractive, similar to gravity, so their orbits around the nucleus will have similarities to stellar orbits. But electrons are repulsed by other electrons, which deviates from gravitational systems. So electrons want to get as far away from each other as possible. So 2 electrons orbiting the same nucleus would probably try to get to opposite sides of the nucleus, which would probably be very similar to the single electron system with simply another electron on the opposite side of the orbit, so you have circles and ovals with electrons opposite each other in sync. It's possible, because of the added electronegativity, that the electrons would push each other to a slightly higher orbit than they would normally have through only momentum or gyroscopic elevation. 3 electrons on a singular nucleus would probably form a triangle. They could be locked in a plane orbiting in circles or ovals. I believe also the third electron could be outside of the plane, so the triangle could be tipped on its side as it rotates. For electrons become much more unstable, the fourth electron, I believe, would form a pyramid. Now suddenly, instead of having a sort of center of gravity, it is balanced in 3 dimensions or more balanced. E.g., 1 through 3 electrons had a 2D plane of gyroscopic force pulling them out flat. But with 4 electrons, suddenly you add depth and you destabilize rotation beyond one plane.